Okay guys, welcome to this video where we are looking at just general exam style questions for the GCSE foundation tier. So the first section looking at GCSE foundation tier, the next slide is looking at higher tier explicitly, and the slide after that, okay, so yeah, it's just three slides today. So the second and third slide, yeah, are explicitly for higher tier students, but this first one, yeah, it is more for foundation, but it's also the crossover topics here between foundation and higher tier. Okay, and it's appropriate for AQA, edX on OCR. So the first question, yeah, section here, so it's just a quick 10 questions. Okay, so question number 1, 23 times 17. So 23 times 17, again, there is more than one way to obviously work this out, okay? So I'm going to do the following. 3 times 7 is 21, so 1 carry the 2. 7 times 2 is 14, plus the 2 is going to be 16. Okay, the next row, okay, I'm going to put a placeholder. 1 times 3 is 3, okay, and 1 times 2 is 2. Okay, now adding my answers together, okay, 1 plus 1 is 1, 6 plus 3 is 9, and 1 plus 2 is 3. So the answer is 391. Okay, again, I can do it via the grid method or the lattice method, okay, or any other method here to like work out my answer, okay, by partitioning the numbers, okay. But it gives me the answer of 391. Question number 2. Share £48 in the ratio 3 to 5. So I'm going to add my ratio parts together. So 3 plus 5 is 8. 48 divided by 8 is 6. So each part is worth £6. Okay, just to make it clear here, so £6 is equal to 1 part. So in 3 parts, that'll be 6 times 3, which is going to be 18. So it's £18 to £30, okay? Because 5 times 6 is 30. So it's £18 to £30, okay? And you can check your answer by adding the numbers together. Okay, 18 plus 30 does indeed equal 48. Okay, so that does confirm my answer. Okay, and this also simplifies back to 3 to 5. Okay, by dividing both parts by 6. Okay, yeah, to work backwards. Okay. Question number 3. Increase 120 by 10%. So I'm going to work out what 10% of 120 is. That'll be 12. Add that on to 120 and I get 132. Okay, 10% of any quantity means divide it by 10. So 10% of 120 here, just to be clear, is 120. Oh, I've put a pound sign there, I apologise, but hopefully you can forgive me, sorry. Okay, 120 divided by 10 is 12. Okay, I'm then going to add that on to 120 because I'm increasing it. Okay, I'm essentially multiplying 120 by 1.1. Okay, and I get 132. Okay, but I added on this 12 to 120 and I get the answer of 132. Okay, when you add it together. Question number 4. Round 324 to one significant figure. So that will be 300. Okay. 3 is my first significant figure, 2 is my second significant figure, and 4 is my third significant figure. Okay, so I'm looking at the second one, it's 5, it's less than 5, so I'm going to round down, so it's going to be 300. Okay. Question number 5, estimate this sum. So I'm going to round each number to one significant figure. 19 goes to 20, and 47 goes to 50. 20 times 50, 20 lots of 50 is 1000, because 2 times 5 is 10, and then add on the 2 zeros, I get 1000. Question number 6, expand this single bracket. 2 lots of x is going to be 2x, and 2 lots of 3 is going to be 6. Okay, that's expanding it or multiplying out a single bracket. Okay, 2 times x is 2x, and 2 times positive 3 is positive 6. Question number 7, solving an equation, I'm going to subtract 2 on both sides to balance the equation respectively. So 3x is equal to 9. Divide both sides by 3. We get that x is equal to 3. Question number 8. What is the lowest common multiple of 15 and 20? Of 15 and 20, sorry. So it's the smallest number that appears in both times tables. So writing out the 15 times tables, 15, 30, 45, okay, 60, 75, okay, 90, and then 105, okay, and then etc, 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 okay, 20, 40, 60, okay, so 60 appears in both, so I don't have to go any further. So 60 is my lowest common multiple. It's the smallest number that appears in both lists. Okay, it's the smallest number that appears in both times tables. Question number 9. Work out 2 plus 3 times 4. So using BIDMAS, I'm going to do 3 times 4 first, which is 12. So I'm going to have 2 plus 12, which is equal to 14. Question number 10. Okay, 2/5 of 35. So I divide by the bottom and then times by the top. So 35 divided by 7 is 5. And then I'm going to multiply 5 by the top key of my fraction, by the numerator. So 5 times 2 is 10. Okay, this is what I call a fraction of an amount. I divide by the denominator and then I multiply by the numerator. Okay, divide by the bottom times by the top. Okay, and that's the end of the first section, guys. This is question number 4, guys, okay, and it's for the higher tier only. The line L1 has equation 4y minus 3x is equal to 10. The line L2 passes through the point 5 minus 1 and minus 1, 8. Determine, giving full reasons for your answer, whether L1 and L2 are parallel, perpendicular, or neither. Well, first of all, the gradient of L1 has to be in the form y is equal to mx plus c. Okay, sorry, it came out a bit big there. So y is equal to mx plus c, where m is your gradient and c is your y-intercept. Okay, so rearranges. So adding 3x to both sides and then dividing through both sides by 4, we get that y is equal to 10 plus 3x all over 4. So the coefficient of x, okay, the number in front of the x, will be 3/4. So the gradient of L1 is equal to 3/4. For L2 to work out the gradient, it's the change in y over the change in x. It's the difference in the y coordinates divided by the difference in the x coordinates. So it's going to be 8 subtract -1, so being very careful there, divided by -1 take away 5. Okay, so it has to be done, yeah, in this order. Okay, so 8 take away -1 will be 9. Here's 8 plus 1, which is 9. And then -1 minus 5 is -6. Okay, so 9 over -6. Oops, should be a 6 there. I apologise. Sorry about my handwriting today, guys. Divide top and bottom by 3, and we get 3 over -2. Now, that's not actually, yeah, perpendicular or parallel, so it's actually neither, okay? Because for a perpendicular gradient, the product of the two gradients has to equal -1. If you multiply 3/4 by -3/2, it doesn't give you -1. It actually gives you -9/8, which is not equal to 1. Okay, so it's actually neither. Okay, parallel means it has the same gradient. Okay, so -3/2 does not equal 3/4, and conversely, 3/4 doesn't equal -3/2. Okay, so the answer is neither. Okay, so neither. Okay, So it's not parallel because it doesn't have the same gradient, and it's not perpendicular because the products of the two gradients does not equal -1. Okay, they are not the negative reciprocal of one another. Okay, the negative reciprocal of this would actually be -4/3. Okay, if you're interested, and the negative reciprocal of this one would be 2/3. Okay, so it is neither one of these two. Okay, so it's neither. Okay, so the final answer is neither. Okay. Question number 19. Circle the fraction that is equivalent to x over 5 plus x over 10. So writing it under a common denominator. So x over 5 is same as 2x over 10 times top and bottom by 2 plus x over 10. We're going to get 3x over 10. Okay, so I'm going to circle option number 1. Okay. Question 20, part A. Write down the value of 7 to the power of 0. Well, anything in maths, so anything to the power of 0 is always equal to 1. Okay, so 7 to the power of 0 is equal to 1. For part B, work out the value of 32 to the power of -3/5. So the minus does the reciprocal, so it's going to be 1 over 32 to the power of 3/5. Oops, sorry about that, guys. I apologize. Let's write it out again. To 3/5. So I'm going to take the fifth root of 32 and then I'm going to cube my answer. So it's the root of the denominator. So it's the fifth root of 32, which is 2, because 2 times 2 times 2 times 2 times 2 is equal to 32. And then I'm going to cube my answer. So 1 over 2 cubed is 1 over 2 times 2 times 2, which is going to be 8. So your final answer is just 1/8. Okay. So just to be clear, guys, okay, the negative is the inverse, so the negative does the reciprocal. Okay, the denominator of my fraction, that's the root that I take, so it's the fifth root of 32, which is 2, and then I raised my answer to the power of the numerator. Okay, so 2 to the power of 3 means 2 times 2 times 2, which is 8. Okay, so I found a set of questions here for the higher tier GCSE Maths, okay, for the AQA. Okay, question number 4. Circle the reciprocal of 5/6. So the reciprocal is just the inverse, so I'm going to swap the top and the bottom, so it's 6 over 5. So the answer is 6/5. I'm going to circle option number 1. Question number 5, use trigonometry to work out the size of angle x. Okay, so this was actually like a non-calculated question here, so it's using our exact trig values. So labeling on sides, that's the opposite, that's the adjacent, and that's the hypotenuse. Okay, so based on that, I'm going to use the cosine. So cos of my angle, so cos of x is equal to the adjacent, which is 9 over 18. So it's 9/18, which simplifies to a half. Okay, dividing top and bottom by 9. Okay, oops, there we go. Okay, should be a 2 there, I apologise. Okay, so cos of an angle is equal to a half. Now, this is all to do with our knowledge on exact trig value. Okay, and exact trig values. So x is actually equal to 60 because cos of 60 is equal to a half. Okay, and sine of 30 is equal to a half. Okay, so cos 60 is equal to a half. Okay, and again, that's just like a rule actually that you'll have to know actually for the foundation and for the higher tier. So cos of 60 is equal to a half. That's also the same as sine of 30. Okay, sine of 30 is equal to a half. Okay, but again, I have got like a separate video here looking at the exact trig values. Okay, now for the purpose of this video here, I don't mind you obviously checking it on your calculator. Okay, because obviously it's obviously part of like a revision process here actually, but obviously remember that in the examinative this question may appear on a non-calculator, so please be mindful here and please learn your exact trig values. Okay, for the foundation tier, they only expect you to know sine 30 and cos 60. Okay, sine 30 is a half and cos 60 is equal to a half. For the higher tier, they want you to know, or expect you to actually know, sine 0, sine, I think, yeah, 30, sine 45, sine 60, and yeah, sine of 90. Okay, and conversely, cos 0, cos 30, cos 60, cos 45, actually, yeah, cos 60, and cos 90. Okay, so make sure, yeah, that you obviously spend time actually, yeah, learning those exact trig values. Okay, for that question. So the answer here is 60 degrees. Question number 26, part A. Show that 14 over root 7 yeah, can be written in the form of a root b, where a and b are integers. So I'm going to rationalize the denominator. I'm going to multiply top and bottom by root 7 to get rid of the surd on the denominator of my fraction. Hence the term rationalize the denominator. So we times top and bottom by root 7. So we get 14 lots of root 7, so 14 root 7 divided by root 7 times root 7, which just goes to root 49, which is equal to 7. Okay, 14 divided by 7, or 14 divided by 7, sorry, yeah, is equal to 2. So my final answer, is equal to 2 root 7. Okay. Sorry guys about my handwriting today, I apologise. Sorry. Question 26. Work out the value of 2 root 10 times root 80 times root 18. Give your answer as an integer. Okay, so I'm going to have, inside the big ratio, I'm going to have 10 times 80 times 18. Okay, and bear in mind, yeah, this is also a non-calculator question. Okay, so no calculators, yeah, for these questions. Okay, so 10 times 80 is going to be, oops, sorry about this, guys, I apologise. So it's going to be 800, okay, times 18. So 8 times 18, and then I'm going to add the 2 zeros at the end. So 8 8s are 64, so 4 carry the 6. 1 times 8 is 8, plus the 6 is going to be 14. So it's going to be the square root of 14,400. Okay. Now that one looks pretty nasty, but hopefully you're happy that the square root of 144 will be 12. Okay, and then I'm just going to add a 0 on, so that will come out as 120. Now reintroduce actually here, so reintroduce actually that 2 at the front. I'm going to have 2 lots of 120, so 2 times 120. So my final answer is 240. Okay, and that's the answer to question 26b. Okay.